Hello, in this video we will be looking at setting the CPU affinity for Pthreads. This can be very useful, specifically in two situations. When you need to reduce the cache miss rate and when you are running the real-time applications or a time-sensitive applications. In this post I will be covering the setting CPU affinity for Pthreads. So let's see how do we do that and how do we verify it. Firstly, we need to get a piece of code that is very CPU intensive. We need to run it in two different threads. Then we can use htop or top or whatever process monitor application that you are using. Then we need to get the maximum number of cores that are available in the CPU. Then we can create a CPU set with one CPU. I'll explain that in a minute how to do that. Then we can start the thread with affinity to that particular CPU set, which means that that particular thread will be scheduled only on those CPU that are present in that particular CPU set. Then we can observe it with htop if the threads are switching the cores or not. So that is how you do it. So let's get started. Let's create a simple file. Let's call it main.c. Let's write a function which will take a lot of CPU power. Then let's write the main function from where we will be invoking this function in two separate threads. Yeah, for that we need to include pthread.h. Let's create pthread th1. Also let's create one more pthread. Let's call it th2. Now let's call this particular function within these two threads. And th2 null CPU intensive function null, and let's wait for these two threads to finish. One comma null. Return 0. Now let's build this. To build this, you just need to do gcc-o. We need to add lp thread lm. Now this is compiled. Let's try running this. Let's also see. You might be able to hear the fan of this particular computer. Let's search for thread demo. Here we can see this particular process is consuming almost 100% of the CPU. Let's kill it. Now it should be okay. We can see that this particular process is consuming a lot of CPU. Now what we need to do is we need to schedule these two threads on two different cores and then try the same tests once again. Now let's create the CPU sets. Let's do it here only. CPU set underscore t, CPU set underscore 1. We need to add CPU underscore, this is the macro. This essentially clears the existing CPU sets and now we can add multiple CPUs to it. Now let's add one single CPU core to this particular CPU set. This is the macro to do this, which is this will add the CPU core number 1 to this particular CPU set, and to add this is how you create a CPU set and you add the CPU core to it. Now let's replicate this for CPU set. Let's do it for this. Let's add CPUs number 2 to this. Now let's set the CPU affinity, and in order to do that you need to call the function pthread underscore set affinity underscore np. You need to do that after creating the thread. So let's do this. Let's say I will create an integer s1 is equal to pthread set affinity underscore np th1. We need to provide the size of that particular CPU set, and to calculate that the function is size of, obviously, and CPU set underscore t, and the actual CPU set. We also need to check if this affinity is successfully set or not. In order to do that, if s1 not equal 0, this function returns the value 0 if in case it succeeded, and if it doesn't succeed then it will return 0, any other number apart from 0. Similarly, let's do the same for CPU set 2. Now we will also have to write this particular macro, that is handle error, which should print a message and then exit. So let's create that macro on top. So this is one way to do it. Since we are using all of those other things, we will have to include a few more headers. We also need to define this underscore GNU source. Now let's compile it once again. Let's call it CPU thread underscore demo underscore AFF, and there is an error. Okay, undefined reference to handle underscore error. Yeah, this was a silly mistake. Let's try to build it once again. Let's try this code once again. Now we are executing. We need to check. Yeah, we can see that this CPU1 and CPU2 are the only CPUs that are being consumed to its 100% capacity, and as we have set the affinity for these two CPU cores, these are the only two CPUs that are being used by the application that we just built. So yeah, that was the demo. Thank you.